company. So if you need any help with JavaScript, GraphQL, serverless, cloud, whatever, we help companies deploy and scale this new type of application. And in the brave new world, we're also a Microsoft partner, but that's another story. So let's go and jump straight on GraphQL. And GraphQL, as you might know that GraphQL was born at Facebook with one big dream. Now, back in 2012, if somebody would have told me that that dream was even possible, I would have laughed. And saying that I would be able to be on stage talking about that technology, I would say, that's never going to happen. This thing is not worth a dime. And they had a dream to create one single API to describe the entirety of Facebook. How do you do that? The thing that was raging at that point in time was REST, representational state transfer. And you're probably all familiar with REST, right? I mean, if you have read the Roy Fielding thesis, PhD thesis about this, yay. If you don't, have a look. It's a fantastic piece of work. I have a PhD myself, so whatever. I love this type of stuff. If you are in science, that's a great piece of thing to read. Let's keep going, though. So you have a nice social network, no brands, so whatever. You have a lot of information in this page, a lot of components, a lot of things that are being shown at any given time. There is, and in here you can see that there is the user information, there is the feed, there are events, there are fundraisers, campaign, whatever. There are birthdays, because you want to show what are your friends' birthday are. And there are people you may know that you might want to become friends with. So there's a lot of information that is being shown on this page. Now, if you wanted to code this page using a REST approach, we will have to provide a lot of different REST endpoints. And I've done this several times, right? You build each of your application with UI with different components. Each one of them call a REST endpoints to fetch their own data. So they have, everything is segregated and independent, so they can be, there's no overlap with the things. We can have an endpoint for the user, an endpoint for the events, an endpoint for friend suggestion, birthdays, and so on and so forth. There's a lot of endpoints, a lot of HTTP calls that we have to do to render this page, to provide this page to the user. Let's look at the events. So there's a nice event called Microsoft Build that you probably know of, that where Satya has done a fantastic keynote yesterday, loved it, and it has some more amazing speakers like Simona and myself. Let's just be humble. And so, and this is information, right? Yeah, well, do we need all, this is our endpoint and what our endpoint returns, but we don't really need the speaker's information to render my view. But for some reason, and this is very typical as well in software, this endpoint returns them because some other client, some other view need those information. So you can see these here, and also you can see that this information is being present both on the left side and the right side. So it's two different components. So if you want to fetch this type of information twice, we might even just get it twice, right? So there is a problem here about, if you want to render this view, are we going overfetching? Are we fetching more data than what we need? Or are we just creating a new endpoint? There's endpoint proliferation strategy here. I don't know how many endpoints your web app has, but they just grow over time. And you don't even know who is using what. That's very typical. And all this software needs to be tested, maintained, and checked for bugs. And QA, I don't know, security. So let's look at another thing, which are the people you may know. And let's look at Golnath. And in this UI, we need to fetch the list of the people that you may know, but also some more things. So
just a quick question here. How many of you know Golnath? How many of you are watching Channel 9? Yeah? Oh, well, 1/3 of the room. Well, Golnath runs the Channel 9 studio, and she ran the Build Live. So we have to be very thankful for that. She does an amazing job.
It's fantastic, Simona. So you go in the friend suggestion, and you see we are not fetching the mutual friends here, right? It's because it's too much work to compute this data. But then you go, and for that, you need to fetch those separately using a different endpoint. And you can see again that we have the list, but we have more data than what we need. So essentially, we are in a conundrum here because we might underfetch at some point to provide a more swift user experience because getting those things is expensive. Or we might just create a new endpoint all over again. And new endpoints, more endpoints. I don't know. I ended up writing a full backend for a mobile app because the API was too complex. So there was a wrapper doing that. I'll tell more about this story later. But so all of those calls, why are all those calls? And what is the problem with REST? Well, the problem with REST is no problem. REST is fantastic. It's scalable, highly performant, cacheable, and it solves all the problem for the web. Minus one thing. The problem is that when we build a web application like that is very interactive, we need to take into account the user experience that we want to provide and not just the scalability of my solution. And with a web app, what we need to consider the perception of a given user. So if you click a button and the UI alters and changes with less than 100 milliseconds, the user will feel that the application is instant and highly performant, very easy to use. If you go up to 300 milliseconds, they will perceive a small delay. Still very happy though. If it goes to 100 seconds, you will start wondering if the system your machine is actually working, if the connection is up. And if you go over 1 second, you just say, well, maybe I'm checking my email while this thing's slow, this is super slow. And over 10 seconds, you just refresh or say, this e-commerce is useless, so I'm not buying from them. And your boss might be very happy and might not be very happy with you. So that might be a problem. So why all of this is important? Well, we need our application to be fast. And if you know that you can only do 4 calls at maximum from a web browser, so if I need to fetch or call all of those endpoints, all of those things will start slowing up our load, so this is problematic. We love this quote from Ilya Grigorik. I don't know if you know Ilya, but he is one of the he's a performance engineer at Google. He did fantastic work on analyzing the performance of web application and network on the network side of things, HTTP 1, HTTP 2, and so on and so forth. There's a lot of nice blog posts that you can read about all those stuff. So go and check him out. But he said that the fastest network request is a network request never made. So yeah, very hard to argue with that. So let's go and jump and see how GraphQL solves these problems. Now, you see here that you have a nice GraphQL. You have this query. And this query part is where we start a GraphQL query. Then we ask for a user here. Now, you see that we ask for user with ID 1, which is the main user of my app. But then we can actually ask for more things. We can ask for the events of this user and the friend suggestions and the mutual friends. And I can issue all these queries on a single network request. And my GraphQL server will go and assemble all this data and send this back to me when all it's ready. So I'm just doing one single HTTP network request. So I'm not paying those 50 to 100 to 200 to half a second, to connect to my servers, because if I'm sitting in Singapore with a very fast fiber optic line, then everything is good and happy. If I am on a hill in Italy, that's kind of problematic, right? It's not, I'm connecting over WiMAX and it's raining and things might not be perfect. So, and then that's important, right? So I can issue one single request. What does the GraphQL server return me? Well, it returns me this data structure that is very similar. It has a data property. I can also have an error property if there was an error in the query. Then I can get my user and the events and with the count, so I'm not fetching all the data, and my friend suggestion with the count as well. So I am actually just only fetching the data that I need for rendering this page. And this is fantastic because the web team might need some data, but the mobile team can need completely different data. So they don't need to reuse the same APIs. They can just reuse. They can just ask for the only data that they need. minimizing the data transfer and the data load, so your system actually loads faster, your application actually loads faster. And you also save energy, so yay, good for the planet. GraphQL is based on a schema. So it's possible because you can actually define a schema for GraphQL. So you define what type of things that you can ask for. And that's fantastic because you can focus on the data modeling side instead of focusing on the APIs. So which type of APIs I need to talk about? No, you just need to focus on the model. You can focus on the domain. In fact, GraphQL can tie very well with a concept called domain-driven design. You probably are familiar with it. And they kind of match together a little nicely. So essentially decoupling the way things work and reducing the amount of communication needed between various teams in your company, which is an extremely powerful thing if you go and think about it that way from an organizational point of view. It enables better collaboration to some extent. It's also strongly typed. So you define each one of those entities that we've talked about is strongly typed. You can define the type. Let's see how that means. So we have a type people. And a people, one of those objects has an ID, which is required. It has an exclamation mark. And it has a name that is a string. And an avatar, picture, URL, whatever it is, that is a URL. Hey. So those things are validated. So the user can only ask for, the developers can only ask for those data. But when we can also add a team, for example, and the team is actually, it has also some other properties, ID, a name, but also has a points, and also can contain an array of people. And, well, but still, those are types, right? So the types are not, where are the queries, right? Because I saw there was a user query before. I can't just query the types directly. Well, in order to query, we need to create a type, we need to define a type query and attach the root queries to it. And for example, we can ask in this schema, we can ask for teams and pass and say that there is a teams query that can return an array of teams. Hey, but also there is a mutation. And what is the mutation? Well, the query provides idempotent operations, while the mutation, it's used to actually change your data. And you might think about it as get and posts, but not as get and posts, because most of the time when we interact with GraphQL, it's actually only posts. So take into consideration that this is the type of, these are some consequences about caching and so on and so forth. So this is how you define your root queries, and you can define a team. The team's root query, where we use Axios or any other HTTP library. We can also call gRPC if you want, or go straight to a database. And we also create increment points in there to do kind of the same very similar thing. However, the clear thing, the most important thing about GraphQL is graphical. So when you define a GraphQL schema, in fact, the GraphQL is self-documenting. So you can see here that when we open Graphical, which is the integrated development environment for GraphQL queries, we can see automatic docs being picked up and being exposed to you. So you can actually browse the schema and know what are the types that can be represented. And it's really cool. And probably the reason why I was able to pick this up that quickly. It's really fantastic. But how do you use this? Let's show you. So you have a query, you start writing your query, and you have autocomplete, because it's fully self-descriptive. So essentially, the graphical endpoint called the graphical UI calls the GraphQL endpoint and asks, what is this schema? What's the schema of this endpoint? And so it can provide all these nice, amazing things. And we can also run our queries as well. It's fantastic. It also shows us if there are problems with the schema. So it also validates our query. So when we run this, we can actually copy and paste it at the end. So essentially validate that our query works perfectly and debug them and so on. It's fantastic. You will see, I will go with doing a live demo sooner rather than later. So let's recap what GraphQL gives us. Performance. on the edge. So it removes network requests, enabling us to provide snappier user interfaces. However, this comes at a cost as all new abstractions. So the complexity of doing all the calls, fetching all the data from the different data sources, is now done on the server. And because of this shift, you need to take this into consideration when you are building and scaling your infrastructure and your architecture. It's also flexible because it reduces, every team now can decide which fields they need, which type of data they need. So you don't have to add one more endpoint for when you need to develop a new client. Imagine that you need to create a new endpoint for a TV in your room. It also has amazing developer tooling, which we love, because this is, goes back into the hype train. However, all of that things, we have talked about those things that happens on the client, on the edge, right? What happens on the server? How do we are going to implement this? It's demo time. So let's see if the demo gods are with me, and let's hope. Finger crossed. So I'm also using Simona's laptop. So again, this is get it to be nice. So I prepared this demo, and I'm just running it with npm run dev on this machine. This just start a server. It's going to use Fastify. It's zoom a bit, Command plus. Yay, fine. Okay, can you see this? I can't hear you, so you need to go to the mic if you want to talk. Sorry.
So instead of adding another endpoint, you're kind of adding more things to the existing API, to the GraphQL API. So one, you're kind of overloading, and how do you deal with single responsibility principle?
Simona, did you get the question?
So I think we're going to spend a bit of time towards the end of the session for questions. So do you mind keeping that in mind, and we're going to review it at the end? Yeah? Can everyone confirm that they're seeing the screen and the text is an okay size? Yeah? Perfect. Wonderful. Thank you.
Perfect. OK. So let's open our graphical user interface, OK? And here we go. So you see that there is a documentation explorer here with our query types, and we can ask for dogs. Do you like dogs? Yes. Yay. OK, I'm a dog person, sorry. If you love cats, I'm sorry. I don't like cats. So you can ask for dogs, and query. Yay. Live demos are all problematic. So you can ask for dogs and ask for the name of the dog, OK? And we run this query, and we return 3 dogs, Max, Charlie, and Buddy. Now, it's nice because also we can ask for the dog owner and in here, and the dog owner also has a name. And yay, we got some more dogs. So it's the dogs and their owner. And you can see that the query matches the results. Okay, it's very similar in structure visually. Now, let's see how this works in the code. So in here, we have defining our schema. You have the type human, and which has a name, which is a string, and a type dog, which has a name and is a string. It has an owner that is a human. And we define our dog's root query that just return an array of dogs. And how do we hook this up? Well, we create some resolvers. That's the concept we use in GraphQL. And in here, we have the dogs query. And basically, we just call our database and get the dogs. And we also log some messages and says getting all dogs. How do we resolve the owner? Now, in a lot of cases, if you're using a relational database or even a NoSQL database, you might store things into different tables or different collections. So you might not be able to fetch all the data on the single query. So essentially, you can specify a resolver for each of the property in the schema. So in this case, if the user wants to get the owner property, this function will be called to get the owner from the database. Now, this means that when we are running our code, we are getting all dogs, and now we are getting 3 times the owner. Do you see what is the problem here? The problem is that we have a 1 + n query problem. So this is not scalable. This is not going to work in production. It's going to have a very bad performance and very bad latency, because at some point our database will say, will just throw the towel and says, I can't handle with this anymore. So how do we fix this? Well, there is a thing. Before going into that, there is one more thing to talk about, because it can even get worse. And let's consider this other schema, which is a nested schema. Let's consider the fact that the owner can also have an address. And you can get as complex as you want here, more levels, OK? Now we move from having a depth of 2 to a depth of 3. But this means that when we are running our code, we are getting all the dogs, getting 3 owners, and then getting 3 addresses from the owners. So essentially, you see that we have the human with the address. And essentially, the problem is getting even more convoluted and even more complicated. We are doing a lot of work. A GraphQL endpoint can actually literally create a little denial of service on your databases if you're not careful. So how do we fix this? Because this seems like a big problem of this technology. Well, there is a solution. And this solution is called data loader. And this is a pattern invented by Facebook. And with data loader, what you do, you create a new data loader when each request comes in. And you create a data loader passing a function in. But the key part here is that it's able to batch all the requests. So essentially, if you want to get the address of a human, for example, what you do, or the owner of a dog, what it does is it takes, I'm asking for the owner of Charlie, of Buddy, and they're taking these 2, it's taking those 2 requests and create a batch request that, it's executed at the same, then you can just go to your database. Instead of doing 2 queries to my database, I can ask for the owners. So I can ask for 2 things at the same time, doing only 1 round trip to the database, reducing the load and the latency of my call. So you see that here we do a bulk query to owners, and here bulk query to address, OK? And we use it in a very similar way as before. Let's see how this goes. So I'm opening this up, and I'm moving to the data loader. And I'm running the query, get the same result as before. But now you see that I'm just doing 3 queries to my database. I moved from a 1 + n problem to just a D problem. I'm only executing as many queries as the depth of my GraphQL endpoint, which is fantastic. In this way, we can reduce a lot of traffic to our database. So, however, it's a little bit convoluted to use. Also, it's currently licensed with the MIT plus patents license of Facebook. So I ended up writing my own thing because to not have that and also to learn something new. So essentially, in Fastify GQL, that is the thing that I'm currently using, I have introduced this concept of loaders. That's basically does the same thing. You just define them as resolvers, and it works just the same. But you don't have to deal with the hooks and create them for the request, and it's all done automatically for you. And when you register them, you just pass the schema, the loaders, and the resolvers, and it all works fine. So let's see how these work. And we go to loaders. And here we go. We run this, and still works fine as before. And if we open up this panel, you can see that it's still doing 3 things. Okay, it's still working the same. And it's highly performant as well. So you should really use this pattern in your GraphQL system. Otherwise, you will have the 1 + n problem, hit the 1 + n problem real quickly. Note that this also has some architectural consequences. So you need to have your microservices and tables and endpoints and so on being able to fetch data in this bulk mode. Otherwise, you won't be able to, you will hit some problems down the line. So keep that into consideration when working with GraphQL, that you might also have to change the other endpoint to integrate well with GraphQL. So as we said, 1 + n query problem. And well, generalizing it is 1 + plus n times m, in fact, is 1 plus n at d minus 1 for arbitrarily complex queries. So that's kind of problematic. This is the link for the data loader pattern. Check this out, very important. And it's not really documented together with GraphQL. So this is, very important to get it together. And it aggregates every query you do in the same tick into a bulk query so that you avoid stuff. It also does some per request caching of already fetched data. So it's really cool. And it's a must-have. You have to use this. Otherwise, big performance problem. So you're probably negating all the benefits that GraphQL is giving you. And you get the queries. I just want to leave by saying that GraphQL removes the need to build platform-specific APIs. So once upon a time, I was writing at that big newspaper trying to building this new mobile app. And we ended up creating a full new mobile API system for iOS. And then guess what? There was the Android team. And we had to customize it again because they wanted different APIs as well. And using GraphQL would have solved our problem 10 times over and being able to ship that product way more quicker. So it's up to you, Simona. Hey.
Thank you so much, Matteo. All right, so Matteo has showed us how to get started with GraphQL using Fastify. And Fastify is a web server that Matteo has created. And it's a traditional type of server. And you can run it in your local, on-premise, in the cloud, wherever you want, in a VM or in a platform as a service. So you can take it anywhere. But in our title, we also mentioned serverless. So I'm going to take GraphQL to serverless. And I'm going to take it into the Azure realm, right? The line of code that's the fastest to write, that never breaks, that doesn't need maintenance, I'm guessing you're already guessing by now, is the line that you never had to write. So I'm taking this back to what Matteo said earlier, where the fastest network request is actually the request that you don't have to make. It's the same concept, where if there's anything that we can leverage so that we make a fewer number of requests or we write a fewer number of lines of code, we definitely have to choose that path. And this is exactly what serverless helps us with. By leveraging other people's services as well as their knowledge to configure and manage servers, we end up writing less code and focusing more on the code that we have to write in order to solve our own problems. So then when we take this to APIs and building APIs, we're basically writing functions that will generate URLs for us. So whenever we're writing a function that listens to HTTP requests, we'll be given a URL, and then that URL becomes public depending on the settings that you're configuring in your platform, and that URL will become public for your users to access as many users as you want, or as many users as your application can support. So then we have serverless, we have GraphQL, but we also need auto scalability, right? We want to be able to grow our user base, and we also want to maintain a reliable performance for our applications. And this is what serverless helps us with. It basically, when we use serverless, we outsource the job of provisioning resources for us and also configuring that scaling knob. So we no longer have to do that. The serverless provider will analyze the incoming number of requests, and based off of that, it will spin up new containers running our code. So you can see in this particular video that we are basically, as we're sending more requests into our API endpoint, you can see that the number of servers that's online for our API grows from 1 to 4 and then to 6. Every 10 seconds, the Azure Functions platform will deploy new instances that will respond to our requests. That's awesome, right? That's really cool. So then, as we take this from simply Azure Functions and serverless code, and we add GraphQL to it, we basically need to initialize in the function code, we need to initialize GraphQL. We need to process every single request through the GraphQL lens. And in practice, there's two things. We've seen that already throughout Matteo's demos. We've seen that we have a GraphQL endpoint that will intercept our requests, but we also have this wonderful tool. We have the graphical interface that allows us to query our application. So we need to make sure, as we're bringing our applications to Azure, we need to make sure that we provide both these elements. And we'll see in a live demo that I'm going to start in a couple of minutes, but basically in our GraphQL endpoint, in Azure Functions, we start with an asynchronous function, and then we initialize our GraphQL function by passing in the schema, the resolvers, any variables or operation names that we might have defined, and then we process that through GraphQL, and we return a response or an error depending on the actual use case. So this is our initializing our GraphQL endpoint, and then our graphical UI is actually, if you're using the one that's being provided by the team, then it's going to be a React single-page application that calls into that endpoint that you can see at line number 4, that calls into our graphical endpoint. And these are the two things that, when you leave this session, you need to remember that you need. So then when we build serverless applications, we build basically reusable APIs that auto-scale. And one thing to remember here, Matteo pointed out this to me yesterday as we were doing the dry runs, that even though it's acquired knowledge, I have to point out that basically when you're building serverless applications, we have this auto-scalability in place, but that doesn't mean that you have to stop thinking about auto-scaling your application. Unless you have a static API that constantly returns the same thing, if you use any database, any storage account, any kind of caching, any kind of other resource that is next to your serverless endpoints, you have to make sure that your application scales as a whole. So always make sure that your database can support as many requests as your serverless endpoint does, right? That's very important. And then there's also easy integration with data sources. In a typical environment, serverless platform like Azure Functions, you're going to find very easy integration between Azure Functions and Azure Cosmos DB. We have bindings that basically help you connect the two resources, and the Azure platform will initialize those connections for you, and it will provision them for you, and you'll only have to declare that you need Cosmos DB. That's true for other types of resources that you're going to find in Azure as well. And finally, there's no servers to manage. That's fantastic, right? As I mentioned earlier, front-end developers don't necessarily have to know how to configure and manage servers. So what about GraphQL and Serverless? As we start building serverless applications, initially we're going to be very shy about migrating to serverless. And that's advisable, right? Start by migrating some of the bits of your application that are tasks that are not critical. So maybe migrate your cron jobs. They're a very good fit for serverless. Migrate your cron jobs, migrate some of the operations that you run every month or so. But as you become more accustomed to serverless, you're going to get very excited about it. I'm telling you, all the applications that I'm building right now, they're all serverless. I find a way, which is not necessarily advisable, because very soon you'll end up with something like this, where you have endpoints in different parts of your application, and you forget about them. The fact that you're not paying for running them, that's fantastic, but still you have to keep control over your endpoints, right? You have to have a good understanding. And this is where GraphQL helps you. Basically, by adding GraphQL in front of your serverless endpoints, you have a quick endpoint or a quick point of access that's also documented. Remember the graphical interface? It gives you access to all the operations that you have available in your API. Combine that with all these scattered serverless endpoints, and you have a gold mine. OK, and I've created a quick tool for you to build-driven development, it's called. I've created this quick npm CLI tool, Create Graphless, that basically generates all the code that you need in order to have all those pieces together, the GraphQL endpoint and the graphical endpoint, and then deploy that application to Azure by creating all the resources needed in Azure, in the cloud, so that you have that deployed. So let's go ahead and jump into the live code. Mo?
Demon gods.
Yeah, let's fingers crossed. So the first thing that we're going to do here is, as I mentioned, this is an npm package. So you're going to be able to install it using all the, like npm install create Graphless. And then there's a couple of options that are available for us. First of all, I can initialize a GitHub repository, and then I can also tell it to install all the npm packages for us. And it's also going to ask me what kind of template do I want to use. So I'm going to go with the simple one, which is the JavaScript Hello World application. So that will generate all the JavaScript resources needed to build this application. The database one will also add all the resources needed to connect to a MongoDB database as well. So our project is ready. And at this point, I can go into my terminal and run npm start. And this will start the entire application for us. It will start an HTTP server that will host our graphical UI, and it will also start the Azure Functions runtime. So right now, we are using Azure Functions in our local on my Mac to run a GraphQL endpoint. And as I click on the URL that's given to me there, you can see here that I've tested this before, and Bly is a very good name for anything that we're testing. But otherwise, we also have access to our documentation explorer. So here you can see which are the operations that I've already created by default, the Hello World application. So now I can run hello, and then name is build, hello build. And I can run this, and this will return the same data. So if we go back to our code, we can see that there's been a couple of things that have been created for us. So first of all, we have this graphical folder, and this is where the React single page application is. So we have this index.html file, and let me just close this. And this is a lot of code. The only thing that you care about is the fact that we are making a request to this website URL, which is defined in this environment.js file. And this is just localhost. This is where our function endpoint is running. So then the next thing that we care about is this Graphless folder. And this is where our function endpoint is. And we start by looking at the function.json object. This is where our functions metadata lives. This is where we tell the Azure Functions runtime that it should listen to HTTP request. This is an HTTP triggered function. The direction is an input direction, and then we accept methods like get or post. And finally, the route that we're listening to is a custom one called GraphQL. That's the convention when creating GraphQL endpoints, to listen to the GraphQL route. And then the response for our endpoint will be an HTTP response. So then in our index.js, we've already seen this code before. Basically, we have an asynchronous function. We initialize the GraphQL function, and we pass in the schema. We pass in the query that comes through the HTTP request, and also the resolvers. So those are the methods that are doing the actual work and retrieving the actual data, either from a database, an existing endpoint. And then we send in any variables or operation names that we might have. This null right here is actually a context object. This is how we share data. This is how we pass data to our resolvers. And if everything goes well, we return the response. Otherwise, we return an exception. And then I go into my resolvers file, and this is where we have our very simple hello world example. This is an asynchronous function, and then our schema is defining only the root type query that returns hello. So we've run this, but this is very static. We don't like static, right? We want to actually imagine the case where you have an existing API, and you want to add GraphQL on top of that. You want to add GraphQL as a thin layer. You've already built an application. You don't want to rewrite it. And this is a very good use case where you add GraphQL on top of an existing API. And the way we would do that, basically, the first thing that I would need to do is go back to my schema, and right here add a new type. We've seen a bit of this before, type team, and then add an ID, add a name. Our team has a name, which is of type string, And then we also have points, which is of type end. And then we have to define a new operation, which is called teams. And our teams returns an array of team object, teams of teams. We've defined our schema. And then the next thing that we need to do is define a resolver for that particular operation. So right now, we've just defined a definition. And then our teams, did you see that magic there? That was very fast, right? Those are VS Code user snippets. I highly recommend them. Basically, I've defined the teams operation, which is an asynchronous method that will call this endpoint, an existing endpoint, and it will return the data for that for us. This is all you need to do in order to add a new operation to GraphQL, at least for this one in particular. So let's go ahead and run this. I'll stop the existing one. Things should work, right? What's the one thing that I haven't done, though? Matteo hasn't paid really good attention. He's not a good sport. What didn't we do? We're using Axios, right?
We haven't not required it.
Yeah.
It's going to crash.
Have we installed it, though?
I don't know.
Let's see.
It's probably on your laptop already.
Yeah, but I haven't installed it. So npm install Axios. And now, if I'm running this.
Yeah, don't worry about the security vulnerability.
Oh, npm start.
Those are overrated.
Yeah. So this is the endpoint that I was mentioning earlier. This is a serverless endpoint as well. So we're calling serverless from serverless inception. Welcome. All right, so let's see if it has started. Things should be OK. If we go back to our local graphical instance, if I refresh this, in our query, we should now have two different operations. So now we have access to teams, which returns team. And then I have this hello query, hello operation, but I can add teams now. And this will return maybe name and points.
Round brackets.
Round brackets. No, it should be OK.
OK, no, it's OK.
It's OK. All right, so now we have executed two different operations within the single query, and we are reading data from an existing API and from the local operation as well. This is fantastic. This is awesome. The other thing that we want to do is we'd want to maybe be able to query a database as well, right? That's something we normally do in a lot of the operations. I'd say that's probably 90% of the software development where we end up querying a database and returning that data. So I have this other...
Who needs database, by the way?
Yeah. I have this other demo, which I'm going to walk through. Basically, in here we have we are reading data from Cosmos DB. So just connecting to Cosmos DB right here, and then in the graphless endpoint, I mentioned earlier that we have access to a context object. So here I'm sending the connection to our database to our resolvers so that we can read data. So now the next thing that we have to go to is our resolvers and see how we're reading that data. So you can see here that I'm reading from the team collection. And then I'm finding a team based on the ID and incrementing those points. And then in our schema, we've added a new operation of type mutation, and we have access to incrementing points for a team based on a given ID. So now if I stop the previous endpoint, and I go to this new demo, and I run npm start, we should have access to the same thing, a graphical interface, where now I know I can execute a hello operation, I can read data from an existing endpoint, and I can also modify, update data in an actual database in Cosmos DB using MongoDB model. All right, so this should be our new graphical instance, and we have access to the mutation we've defined, increment points. So in order to execute that, I have to add the operation, increment points based on ID. ID 1 is the red team, and then I want to see the actual points. We want to make sure that this gets actually incremented. So if I run this, you'll see that the number of points gets increased with each operation call that I make.
Can I increase points for another team?
Only if you want to. But you're right, green is my favorite one.
I know.
Awesome, cool. So we've seen a couple of things here. And before I move on, we also want to, basically, right now, we are running this in our local. But Azure Functions is even cooler when we run it in the cloud, right? So you can take Azure Functions on your premise because it's open source, it's on GitHub, so you can add it to your own environment as well. But if you want to leverage the cloud in Azure, we'd want to push our code to Azure. And I've created, how many of you are familiar with the Azure Resource Manager, ARM templates? Yeah? Awesome. How many of you? Well, you've learned. How many of you are using the Azure CLI? Fantastic. That's half the room. OK, so now I'm going to use this script that I've created where we're going to deploy all of this. We're going to create the infrastructure for our code to be deployed. We need a name.
Near for 1, 2, 3.
Near for... That's terrible.
I know.
It has to be unique, though. This name is going to be part of our URL for our function endpoint, so we have to make sure that it's a unique one. And as this is deploying, it's probably going to take around 2 or 3 minutes. Let's have a look at what we've created here. So if I go into scripts and deployment, you'll see here the familiar Azure CLI and some of the we're going to have a look at the template that I've created as well. So first of all, you can see that I'm creating a new resource group here. And for those of you who are not familiar with Azure, a resource group, it's almost like a folder where you're putting all the resources that are related in the same resource group so that you can manage them together. You can deploy them at the same time. You can remove them at the same time. That becomes very handy. So we're creating a new resource group with the name that Matteo has suggested, Nearform 1, 2, 3.
4.
Very
1, 2, 3,
4. And then Azure has now this new feature in Azure Storage. We have support for static websites. But in order to enable them, we have to add the extension storage preview within the Azure CLI, or you can go into the portal and enable that as well. And then the next thing that we do is actually deploy the template that defines all the resources that we need for our GraphQL endpoint and our graphical interface. And then there's a couple more things where I'm adding the default file that's going to be run, and also cores. This is a love and hate relationship, right? We love security, but we also love it. We also hate it. So because our graphical interface is going to be hosted in a different, is going to have a different URL than our GraphQL endpoint, we have to add that as a rule in our functions settings. So we do that using the Azure CLI as well. You can do it in the portal too. And then let's have a look at the actual template here. There's tons of things happening here, but if you're using VS Code, there's this thing called the ARM template outline, where you have access to the schema definition, the version that that this template is, the list of parameters that your template accepts, as well as the resources, the list of resources that you're defining. So you can see here that we're creating a storage account. This is where our code is going to be stored. The code for the function that's deployed in containers is stored in a storage account. We're also creating a new plan. So with functions, you can use either a consumption plan, or you can use an app service plan, which is an always-on plan. So you kind of pay a monthly bill. With the consumption one, you only pay for what you're using. And I highly recommend that one, especially if you're just getting started with serverless. And then there's a new one that has been announced recently, which is the premium plan. One of the things that you might encounter early on with serverless is this thing called cold start. Or if you're an optimist, it's called how? warm-up time? Yeah? So with Premium, what we get is the best of both worlds, where basically you're still running on some kind of consumption plan, but the platform will always make sure that there's a number of instances that are always on, so that your users don't hit that cold start. The cold start is basically the amount of time that we need to get your code from your storage account into and then deploy an instance that will run your code, install all of the dependencies that you might have into your application, and then run the requests. That only happens when nobody's making calls to your API. So it doesn't always happen. And then we're also creating the function app. I think we can move to the actual portal to see the status of our deployment. So you can see here that previously Matteo has agreed to use a Matteo name, but now he's changed his mind. So now we're looking for Nearform. So this is the resource group that we've just created, and we can see the list of deployments here. And we have one which has succeeded already, and we have access to all the resources that have been created for Azure right here. So now if I go into the Nearform123 website, this is where our Azure Functions code is. And what do you think, Matteo? Is this going to work?
No, it's not going to work.
You're supposed to say yes, Matteo. So
I'm a pessimist. She's an optimist, and I'm the pessimist.
So this is our graphical interface that we've seen in our local. We've created a storage account, a static website in Azure, and now it's available at nearform123.z22webcore, blah, blah, blah. And then we can see that actually our documentation is not available. No schema is available.
It's not working.
No.
I'm a pessimist.
Any idea why?
It never works. My stuff never works on the first go.
Yeah, but this was my stuff. Any idea why this is not working? Anyone? What did we do previously? We connected to a database, right? Where do you store your database secrets?
In my head. It's all in my head.
I wish I had his head to be able to remember all those passwords that are really not 123. That's not a good password. But yeah, we store secrets in application settings, right? And with Azure, well, or in Key Vault. But for now, we're going to look at application settings, and this is where we have in our code, we have in our local, we have defined a couple of secrets here, like our user, our port, and our password in local.settings.json. But when we created those new resources in the cloud, we never send these because we don't store them in GitHub, and we never send the local.settings.json file. So what we have to do in order for our application to work, we have to update it and include these settings. And I've created a quick cheat sheet here. So I'll go back to my function. And then in the portal, I can go into application settings and click advanced edit. And right here, I can paste all those settings that we had in our local, and everything was working fine. We could connect to our database. I'm going to save this. And now we should be able to easily connect again. So if I refresh this, ideally, things should work. And it's taking a while.
Cold start.
This is the cold start.
I'm a pessimist.
Or the warm-up time.
It's the warm-up time.
Yeah. Remind me to come back to this as we're moving through our slides. So what we've just seen here is a client connecting to our GraphQL endpoint, and then that GraphQL endpoint was reading data from an existing endpoint, from an existing Azure function, and we would query a database for that. We could as well, in our GraphQL endpoint, read data from directly from our database, or even add a Redis cache or a cache in general to read data from. The basic idea that you need to remember from this is that with GraphQL, we can easily abstract the data source. So our client doesn't really care about where do we read our data from. And then ideally, we also want to have a different type of client that's reading data. That's where GraphQL performs the best. So with serverless, if we put them side by side, with serverless, we get easy integration of data sources. And with GraphQL, we get an easy abstraction of our data sources. With serverless, we get auto-scalability for our endpoints. And with GraphQL, we get a single endpoint. That's magic. That's like best match. And then with serverless, we get less code. And with GraphQL, a smaller number of requests. So get ready for this. This is where we discover the thing that both of them have in common. Ooh. Developer productivity. That's the #1 thing that all developers love, right? Any kind of tool that makes me faster, makes me build more performant code.
We just love them. Like, we take it. Like,
yeah. Yay. You don't agree. We have someone that... That's cool. So eventually, we're going to achieve more by doing less. And this is a list of resources that we've put together for you. The first couple of ones are pointing to some of the Azure resources that I've used. And then you also have access to Fastify and Fastify GQL. And the tool that I've made, Create Graphless. Make sure to check it out and send all of your questions to us. Let's just see if
it works.
Yeah,
if it works,
we have to.
You know, the warm-up time.
Yeah.
No, it's not called cold start.
All right, so now we have
work.
our query. Yeah? Awesome. I can also execute a quick query here just to make sure that things are, well, yeah. I think we're running out of time, though.
Yeah, they're kicking us out.
Cool, so thank you so much, everyone. We are super excited for you to build things with GraphQL and serverless, and make sure that you reach out if you have any questions.
Also, we will probably be outside if you have any questions, but you probably will be at your booth, right?
Yeah. Come to the JavaScript and TypeScript area in the hub area. I'm going to be around the entire day.
Bye-bye.
Thank you.